In this illustration, we intend to simulate moment frame under the cyclic loading in the Abaqus software. In the right picture, you can observe the model having been made in the laboratory, and in the left picture, the model having been simulated in the Abaqus software can be observed. In this problem, a cyclic loading is applied to the moment frame, and then its hysteresis diagram will be drawn. In this picture, the hysteresis diagram obtained from the Abaqus software has been compared with the laboratory results. In these pictures, the formation of the model under the cyclic loading can be observed. Actually, we intend to simulate this article in the Abaqus software. The article is entitled Cyclic Behavior of Moment Frames with Conventional or Slit Infills. I will enter the Abaqus software for simulation. I will click on Create Part. I intend to create geometric shape of the beam. I will select the modeling space as 3D, deformable, then select Shell and Extrusion, enter approximate size equal to 1000 and continue. As you observe in this picture, the type of beam is IPE 220, the specifications of which can be observed here. The size of web is 220 millimeters, and the size of flange is 110 millimeters. The size of the beam is equal to 1240 millimeters. The distance between these 2 points is equal to 170 millimeters. The length of this line is equal to 120 millimeters. The distance between these two lines is equal to 100 millimeters. The length of this line is equal to 50 millimeters. Young modulus is equal to 206 gigapascal. I will enter Young modulus equal to 206,000 megapascal, and Poisson ratio is equal to 0.3. In the next step, I will click on Mechanical menu. Here select Plasticity and Plastic. Yield stress is equal to 364 megapascal. In the next step, we intend to draw the hysteresis diagram of the moment frame. Actually, we intend to draw this diagram in the Abaqus software, and here the horizontal axis will be displacement and the vertical axis is force. I will click on Create XY Data, select ODB Field Output, Continue. Here I will select Unique Nodal, then RF3, and after that U3. Here I will select Set 3, that is related to the place of cyclic loading, and click on Save. I will click on Create XY Data, select Operate on XY Data, Continue. Here we should add all reaction forces together. I will click on Combine. First select U3, then select Force and click on Save As. Here you observe the hysteresis diagram of the model. I will transfer the diagram to the Excel software. The first column is displacement, the unit of which is millimeter. The second column is force, the unit of which is Newton. Here, the diagram having been drawn with red color is the one having been obtained from the Abaqus software. As you observe, there is a good conformity between the results obtained from the Abaqus software with those mentioned in the article. Actually, the results obtained from the Abaqus software are close to the results gained from the laboratory tests, indicating that the question has been simulated properly and correctly in the Abaqus software.